Hello everyone. In this lecture, we are going to understand how we can calculate the population that is under the risk of earthquakes greater than 7 magnitude, and or in future if some major earthquake occur in the Himalayan belt, okay, in the Indian Himalayan belt. So we will only consider Indian part of the Himalayas to do these calculation. So first of course, we are going to save our data. Okay. So for that, after that, your project home will be created. Okay. And it contains all the information, all the files that you will require for this exercise. All right. So our first task is to bring the India country boundary shapefile using drag and drop. Okay, so this is the administrative boundary of of India. Okay, so yes, so next we need is the aggregated TIFF file of population. Okay, so this is a raster data provided, like this is available on the internet. I'll provide you the resource, okay, from where I got this data. And you can use the same data for different time interval. They have a data of the year 2000, and this data is actually available in the grid size of 1 kilometer by 1 kilometers. Okay, and it provides you the population which is living within 1 kilometer by 1 kilometer. Okay, so you if you let's first drag and drop this data. Okay, see here entire area is represented by this black line. Okay, now we will learn how we can improve the visualization of our raster data. In this way, this is not possible for you to see any sort of information here. Okay, and you do not have your legend is even not telling you the so it actually the values are distributed from 0 to 1,86,955. Okay, so these many values are there. Of course, we know that in 1 kilometer by 1 kilometer, these many people, it's not possible that they live in just by 1 kilometer by 1 kilometer. Okay, so some of the data is not necessary, and we will see how we can filter that out. Okay, so for that, first let's use the layer styling panel. Okay, so this is a brush like icon in your layers browser. So you click on this and see it says that this is a single band gray data. Okay, let's bring it to let's try giving it different colors. Okay, so we'll provide it some pseudo colors. Now you can see there are some green spots. Okay, and these green spots represent the higher values. Okay, but you see your white values are not visible. That means that somewhere means that these values are very less, maybe just few pixels are there, right? And uh, we cannot compromise with the the high frequency data, just because we want only one or two higher values. So let's filter them. Okay, we don't need all these values. So how we can do that? Let's first compute the histogram for this raster data. Okay, so if you click on this graph like icon here, so, okay, this is your histogram. Then you have to click on compute histogram. Okay, so if I just let me make this bigger. Okay, yes, see, if you see this, you see a flat line here. Okay, and your maximum data and most of your data frequency is within 0 to maybe this value. Okay, we don't know right now what is the value. Let's see, this is 50,000, 40,000, 30,000, 20,000, and 10,000. Definitely these values are less than 10,000. Okay, so our first filter will be, we will filter our maximum value to at least 10,000. Okay, see, With 10,000 we are able to see our other colors as well. Okay, still we are not able to see the entire color ramp. Okay, and or let's say we want to stretch our color ramp from 0 to our maximum number of values. Okay, we want maximum number of values. So again, when we have stretched our histogram, you will see a slight jump here. Okay, slight drop here of the data, right? So let's see how much this value will be. This is 4,000 and this is going to be 3,000. Okay, so let's change our value to 3,000, where there is, there is, if I'll zoom here, then okay, let's go back. Yes, so if I zoom here, you will see a slight, data is are slightly inclined. Okay, let's zoom in this area. See, can you see this? So exactly this drop is at 3,000. Okay, so let's fix our maximum value to 3,000. Okay, see, now we have stretched our color ramp, we have stretched our colors from 0 to 3,000. You must have learned this concept of stretching, okay, to make your image or your raster file look much better for data visualization. Okay, right? So if you zoom in here, right, so this is your white patch, and everything greater than 3,000 is given white color. Okay, and if you want, you can also double click and you can also change this color. See, all these red spots are highly dense, highly dense areas, or highly populated regions of India, and all these red spots are actually major city centers. For example, this is your Delhi. Okay, so I hope this is clear, and this, right, these are other cities. Okay, yes. Now let's go back to our further analysis. Okay, so here you got your raster map which shows the population distribution, okay, from 0 to 3,000. All right, if you want to see those values, you click on identify feature and click on any of the pixel. Okay, so let's say this pixel. I will click here on this pixel and it will ask you which value or which file you want to consider for identifying this particular pixel. Okay, I'll go with the TIFF, and it says that there are 617 people living in this within this pixel. Okay, okay, now I'll proceed further to our analysis. Okay, so we have added our raster data, we have added our vector data, I mean shape file format. Now let's add our CSV data. Okay, so as I usually say, that you should never add your CSV data using drag and drop, because if you will come to this window, open data source manager, and if you for CSV you have to select this delimited text layer. Okay, and then if you click on these three dots, here you have seismic moment.csv. Okay, click on open, and right, so if you come in file format, then you have to use your delimiters to separate your values. Okay, for that, here we are going to use tab and comma. Okay, and in point coordinates, so in our previous exercise we used no geometry. Why? Uh, because that particular file didn't had any spatial information, it didn't had any latitude or longitude points, so that our data knows where to go. Okay, it didn't had anything, so in that case you will always use no geometry. But if your CSV file have your point coordinates, okay, latitude and longitude values, so in that case you will use this point coordinate, because when I hover my mouse, you will see geometry is a point defined by x and y coordinate fields. Okay, so here our CSV file have latitude and longitude values. So before you add your CSV file, I suggest that you look into it in your external software like Microsoft Excel or any other thing you use. Okay, So now when we have seen our data, when we have seen, okay, it is perfect. So these are of course numbers. Then for that you always use integer. Okay, these are decimal values, then this decimal double and decimal double, because these are all decimal values. So if you want any extra information about, if you want to learn any extra information about anything here, so just keep your mouse over that particular button and it will tell you it will provide you the extra information. Okay, right. So when we are done with this window, I'll click on add and I'll click on close. Okay, see, can you see all these orange dots? Okay, are, you know, they are marked over India. So because some of them are hiding behind, so I'll bring this at the top. Now you can see all of them. Okay, now let's make them let's add some symbology to it. Okay, let's see, because they are all of different magnitude, different locations of earthquake that were of different magnitude. Okay, and now I will add symbology according to the magnitude value. Okay, so what I will do, I'll go to my layers panel. Okay, layers styling panel. All right, see, it has taken this particular layer itself. Sometimes when your layer is not clicked here, then it won't take it here. So for that, what you have to do, you have to select your layer using this drop down menu. Okay, drop down menu, right? So for that, now I'll use let's say graduated. Okay, I'll use a graduated because these are numbers and we want to categorize them. Okay, like 6 to 7, 7 to 8, in this way. All right, we don't want every magnitude to have different sizes of circle. We just want some categories. So in such cases you use graduated classification. Okay, and so these values will be based on MW. Okay, our moment magnitude. Okay, right. So now let's add a symbol to it. So I'll use let's say let's use based on size. Okay, it will change based on size, and I will give it red color. Okay, I'll give our stroke color will be red, and let's say we'll provide it red color for our fill and for stroke as well. Okay, and I'll go back, and here in in place of this color ramp, you use, sorry, in place of this method you use size. All right, you use size from 1 to 8. Okay, or you can also change it to 2 if you want to stretch it from 2 to 8, and then click on classify. Okay, see, we have red color circles of different sizes. Different sizes represent a different magnitude. Okay, all right. So I think 8 doesn't look good. So I'll change it to 6. Let's say how it looks. Yeah, it looks better. And also I don't like the stroke color to be red. So I'll give it black. Okay, so that it is differentiated from each other. All right. So I will also want to reduce the size again. I'll keep it 5. Yeah, this looks better. Okay, yes, see, you can change your counts and you can also change your intervals, right? 6 to 6.54, you can also manually define them, right? You go to values and double click here, and let's say you want 6.5. Okay, then 6.5 to 7. Okay, then 7 to 7.5. So you are putting equal intervals. 7.5 to let's say 8. Okay, right. Then 8 to 8.7. All right, so we can define our own intervals as well by double ticking here. Okay, and you can also change the legends. Okay, right. Now yes, we are done with the symbology based on the magnitude. Okay, you can also put the labels, right? You go to this icon, this is ABC, and if you want single labels, Then yeah, maybe you can also put the years, right? So this data is like 1842, 1519, right? This is this is a historical data of earthquakes, okay, which I collected from one of the research papers, okay. Right. Yes. So if you want, you can keep it bold. Okay. And let's say I'll change the font size. And actually, I don't want it to be with using here. I want it to be using magnitude values. Okay. And yes, I mean, you can use different options. There is option for placements. There are option for callouts, and you can add buffers to your values. All right. Yes, so we will close this window now. Yes, now you must be thinking that there are, some of the earthquakes that are not that didn't happen in within India. Okay, so now I will remove such values which are out of our area of interest. Okay, basically you can apply this technique to everywhere wherever you want to filter out your data. Okay, or wherever you want to filter out the data based on the spatial, based on the area of interest. Okay, so how we can do that? Because you see, these are your CSV and your mask. You have a mask layer of Indian country boundary. Okay, you have this mask layer as a shape file. So what you will do, you will go to vector, you will go to geoprocessing tools, you will clip it. Okay, what you want to clip? You want to clip out your seismic moment layer, and you want to use the overlay layer. Okay, based on this overlay layer, your data will be clipped out. Then click on run. Yes, it's done. See? So all the data which had, which was outside the Indian boundary has been filtered out. Okay. So quickly I will add a symbology to it in the same way that I did for our seismic moment data. Okay. I will use red color here, and let's say I will use size and I'll classify. Okay, and I'll give it equal interval. I'll reduce the classes. Okay, okay, let's say I'll keep it 4. Okay, yeah, I mean, I can manually define it, but that's not a problem, right? Okay, when we are done with our data, so what is the next thing? Now let's understand what is seismic moment. Okay, so seismic is, of course, the word is related to earthquakes. Okay, so seismic moment is basically, it gives us the measure of the size. Okay, how big the earthquakes or how small the earthquake was, based on the concept of rupture. Because whenever there is slip along the fault plane, so there is rupture. Okay, or whenever there is the sudden energy release, so that energy release causes rupture along the pre-existing fault planes, and it slips, right? And the surface slips, okay, along a fault plane as a rotational motion. Okay, about a point, right? So there a point about which rotational motion is caused, and that point is on the is should be on the fault plane. Okay, so because of the shaking, energy is released. Okay, so how the energy changes? So whenever there is increase in the magnitude, like if your magnitude earthquake increases from 6 to 7, suppose there was an earthquake of 6 and then there was an earthquake of 7. Okay, so the energy difference will be 32 times. So uh, 32 times between 6 and 7 magnitude earthquake. Okay, and also there is increase in the amplitude, so the increase is approximately tenfold. Okay, so I hope that this is clear that your 7 magnitude earthquake will cause 32 times more energy release than what your 6 earthquake magnitude can cause. Okay, and same applies for your 7 to 8 jump in the magnitude. Okay, I hope the concept is clear. Now, for if we see our magnitude, it ranges from 6 to 8.7. So the energy or the maximum energy will be released for 7 and 8 magnitude earthquake. Okay, the more energy. So now within using all this data, I want to filter out only earthquakes that had magnitude greater than that were or equal to 7 or greater than 7. Let's see what we are left with now. Okay, of course the analysis that we are going to do, you can use those analysis in the entire data, but for now I will just filter out. Okay, so how we can filter out? I'll go to the same file in which we are working, we are using, right? I'll click here and I'll use this filter option. Okay, I'll come here and I'll use this filter option. Okay, so what we want our magnitude. Go to fields, click on magnitude. Okay, greater than equal to what you want, you can get all your values, right? 7. Double click to select your values. Okay, then let's say I'll go with okay. See, we got all our earthquakes that are greater than 7. Okay, did you see? Yes, right. One more thing you must be noticing, if I close this for now, that can you see the clustering here? See, can you see the earthquakes are clustered over this region, right? Here there is no such clustering, but in this region there is a clustering. Okay, so right, so there is a clustering. Now let's see how we can represent our data when we have clustering of such kind. Okay, when you have clustering of your points, right? So how can you add which symbol you should use when you have clustered data? Okay, so for data is a generalized term, you can use any sort of data. If you have crime data for some location, right, you can apply this concept there as well. Filter out, suppose you have different type of crime data, right? Different type of crimes are happening in particular city. Now you want to see whether this whether sorry, first of all, you can see, you can categorize your data based on the type of crimes, right? And the frequency, the how frequently they are occurring, right? You can use this concept in your crime data as well, and you can think about the more projects all by yourself. Okay, yes. So if there are different type of crimes, you can first categorize them, right? And you can categorize, you can at that time you can use categorized type of classification values. Okay, and then if you want particular type of, if you think that okay, there are more thefts going on in this particular area, okay, in this particular city, so now you can categorize the frequency. Okay, and if you find such clustering, suppose this is a city where a lot of theft incidences are occurring. Okay, so you get such kind of clustering. So again, you have the cluster data, how you can use it, how you can symbolize it. I'll go to again my open layer styling panel. Okay, for this I'll use heat map. Okay, let's say I use my heat map. See, wherever I had my clustering, data clustering, okay, I got the uh, let's make it here. See, here I had the clustering, right? And here I have the clustering, right? So this is the area where most of the uh, incidences are happening, right? Most of the earthquakes are occurring of 7 magnitude. Okay, right. Now let's change the color ramp. Let's give it greens. Okay, see, there is a green spot in the region, right? Okay, so this is how you can you know, give it symbology, right? And edit your colors. All right. See, now let's go to our clipped. Okay, I'll remove the symbology for now. Okay, I'll give it single symbol or graduated. So wherever we were, right? Okay, so here you got back to your data. So in the same way, if you want to see your clustering of data, you can use heat map. Okay, now next thing is, let's learn how we can create spatial join. Okay, so before we create spatial join, let's look into the data that we have. Okay, and how you can do that, let's see where is our attribute table. So you can open your attribute table using the right click and go to open attribute table option. Okay, and otherwise you have this icon in your project toolbar. Okay, so you click on this and you can see your data. Okay, see this location, if you come here you have latitude and longitudes. Okay, so let's keep it open. Next, if you come here, you see this attribute table, you just have area. Okay, here if you see you just have the value of area, right? You don't have sorry, yes, if you compare these two tables, you do not have latitude and longitude area, latitude and longitude values here. Okay, so let's see how we can connect these two tables. Okay, I'll close them. I'll just close these tables and let's go back to our QGIS. Okay, so we want this, you know, these points to, or this shape file to get the latitude longitude values using these points. Okay, so for that what you will do, you will create a spatial join. Okay, okay, so for that you will go to join attributes by location. Okay, so your in which layer you want to join your features, you want to join your features in seismic moment or this, you can use anything. Okay, and what, so and how you want to you know, predicate these features. You want them to be like, you want all the features that just intersect or are within, contain, equal, or overlap. I mean, you can add as many options you want. Okay, and by comparing to, on which layer you are comparing to, you are comparing to India country boundary. Okay, so let's click on run and see what we get. Okay, so we got our joint layer. I'll click on close, and if I see the attribute table, see my both my tables are, you know, joined together, and we got the area, okay, of this boundary, and we got the latitude and longitude. In this way you can add your spatial and non-spatial data, or the data which have latitude longitude values and the data which do not have latitude longitude values. But the thing is, you should at least have something in common. Okay, in this case your overlapping of two layers became your primary key. Okay, and yesterday we learned that the name one field value became our you know, primary key. Okay, yes, so this is how you can create spatial joins. Okay, now let's perform our analysis, and let's understand how we can calculate the population that is under the risk of, you know, major earthquakes, right? Major earthquakes like these that are occurring in the Himalayan region. Okay, so what I will do for that, first I will add buffers. Okay, so for that you type buffer in your locator toolbar, click on buffer. So which layer you want to use? You want to use your clipped layer. Okay, you want to create buffers around these points. Okay, and distance, because this is in degrees, we haven't changed it to our projected coordinate system because we are working for with the entire, you know, a big country. We cannot project, because and this country have different UTM zones, right? We cannot use one projection here, so we will just use degrees. If you are working in a region which just falls in one UTM zone, single UTM zone, okay, then you have, in that case, you have to change your projection coordinate system, okay. So the 10 degrees is too much value, so I will use 1 degree, okay. All right, so how many segments? Segments, let's say we want 10 segments, okay. And let's see how it goes. Click on run. I'll close. See, you got your buffers, okay. I'll bring it to the top, and I'll bring this to the top. See, these are the earthquake points around which 1 degree of buffers are created, okay. And what information, we have created a 1 degree of buffer, and we will see what how many number of population and how much average number of population will be affected if in future at all this sort of earthquakes is occurring, or it gets repeated in the same area, okay. We will calculate that now. For that, what you will do, so you have created a zone, okay. So when you have created a zone, you need to perform zonal statistics, okay. You need to perform your zonal statistics. So for that, you will need your buffered layer, okay, around which you will create analysis. And which raster data you need? You need now population raster data. I hope this is getting clear. And what statistics you want to calculate? If you want, I won't count sum and mean, but if you want to change, you can click on these three dots and you can select anything you want, okay. We'll go with the default. We'll calculate count, sum, and mean, okay. This is again will be created in your temporary form, okay, temporary scratch layer. Now let's click on run. Right, see, our buffers are sorry, the QGIS processing has calculated zonal statistics around these buffers, and these buffers or these temporary layers will give us the value of count, sum, and mean population that will be affected during these events, okay. And this population count is based on 2020, okay. So after 2020, of course, there is increase in the population in all these regions, okay. So we will just consider the data till 2020, okay, and we will see how we can do that. Now simply what you do, you click on your identify feature, okay, and then you click on any of the buffer, okay. I'll click on, okay, let's say actually here at the top part we do not have the data, we do not have this raster data, okay. But it if you come here, if you see in this region, see, when you left click, it will ask you which layer you want to use for zonal statistics. Okay, you want to use India populated, okay, or you want to use zonal statistics. So it is also giving you information. So this earthquake is from 1905. You can also identify all. Okay, so I'll go with zonal statistics. See, it has given you the count. Count is the number of pixels, okay. So in 1 kilometer, in 1 kilometer by 1 kilometer, it gives you the number of people, okay. And this is the sum or sum of the pixel values, okay, the sum of all the pixel values, okay. So this is the number of sum of the population, okay. And this is the mean population, that is going to mean of the pixel values that are that is enclosed by this buffer, okay. I hope this is clear. So this is the actual population that is going to be affected within 1 degree if such earthquake would have occurred in 2020. I mean, so this earthquake was on like 1905 earthquake, okay. And if I remember correctly, approximately 20,000 people were affected from this earthquake. But if this earthquake would have occurred in 2020, these many people would have been affected. Okay, so I hope this is clear. And similarly, you can make the analysis for so you see it also asks you like which earthquake, I mean which buffer you want to use. Okay, let's say you want 1833. See, so these many people were affected. Okay, so I hope this is clear. Okay, so this value is approximately 3.6 crores. Okay, and of course the earthquake intensity is decreased when it is away from the epicenter. So this was the epicenter. Of course, I mean, of course all these people will not be affected equally, right? And the people closer, so that's why in this case you also, when you are doing analysis with the earthquake data, you also have to check the intensity zones. Okay, so you calculate these buffers within the intensity zone, within the high intensity zone. So that's where you get the actual sum or actual number. So these are the number of pixels, okay, which falls within this buffer, within this zonal statistics area. Okay, so I hope this exercise is clear to you. Okay, and see here you have approximately 3.4 crores. Okay, I hope this is clear, right? So this is a simple exercise. Here you can plot all sort of data and you can perform such analysis, right? And so yes, so this is the end of our exercise in which we learned how we can calculate the population under risk or anything under risk. Okay, under the risk of earthquake or any sort of natural hazard, you can apply this natural, man-made, or crime rates, or something. Okay, you can also use this concept if you want, if someone wants to open their own business, and if you want to see if I open this particular business in this specific area, then how many people I'm going to cover. Okay, so this buffer analysis and zonal statistics approach can be used in that case as well. Okay, yes, so I hope you have learned a little bit, and do let me know if you are stuck anywhere, and if you have any questions, please do send me your queries. Okay, so I will end this session for now, and this is how your final map looks like. Okay, and you can use this information wherever you want. Okay, okay, then I'll see you in the next lecture. Okay, bye bye.